Hello everyone, this is lesson 11.2, areas of sectors. So yesterday we learned the area of a sector formula, which is the measure of the arc divided by 360. And remember that this gives you the fraction of the arc that or the fraction of the circle that you're trying to get the area of, and then multiplied by the area of a circle, pi r squared. So for this lesson, finding the actual area of the sector is not hard. What gets a little bit tricky is when you're finding the measure of the arc and you're given the area, or if you're finding the radius, because then you would have to do the square root and get r by itself in this crazy messy equation. So we'll make sure we touch on a good amount of those examples today. So for the number 1, it says that the measure of the arc is 60, the radius of the circle is 12. So you would do 60 over 360. And I'm just going to go ahead and simplify that first to be 1/6. So we'll have 1/6 times pi times 12 squared. And 12 squared is 144. And you might want your calculator because we're going to do some simplifying here. So if I take 144 and divide it by 6, because that would be the fraction, alpha y equals 144 divided by 6 simplifies to 24. Okay, so the answer then would be 24 pi, and then meters squared, because we're working with area. All right, so these ones are similar. This would be, I'm just going to set up the equation, and then you would just simplify. So 1/4 pi times 6 squared, which would be 36. I guess I will work this one out. So this would be 36 pi. Sorry, I don't know why I said cubed. 36 pi over 4, and 36 over 4 simplifies to 9 pi. And then for this one, you would have 1/3, because they're saying that these are congruent, so this is 1/3 of the piece, times pi times 24 squared, and then 24 squared. Gives you that number, divided by 3, gives you 192. So this would be 192 pi feet squared. Okay, so those are our basic examples. This one is area, that's nothing new. This one is find the radius. So here we'll have to work backwards. They give us what the area is, so we'll say 54 pi equals, we know the fraction, 45 over 360, and I'm going to check in my calculator what 45 over 360 is, so I can simplify it. That gives us 1/8. Probably could have already figured that out. If 90 over 360 is 1/4, 45 over 360 is 1/8. So that's 1/8 times pi times the radius squared, which is what we're trying to find. So the first step you would want to do is to cancel out the pi's if you can. All right, sometimes you can't, and we'll discuss that in a different example. Okay, and then you would want to get this 1/8 onto the other side. Now, instead of dividing both sides by 1/8, think about multiplying by the reciprocal, which would be 8 over 1. So we're going to take 8 times 54, and that gives us 432 equals r squared, and then we'll take the square root of that. I wouldn't ask you to do simplest radical form with 432, maybe a smaller number, but that would be a little bit of a headache. Okay, so 20.78 would be the radius. 20.78. Okay. And then units, meters. All right, so here it says to find the circumference of a circle if the area of a sector is 40 pi. So this is a very similar example, and we want to find the circumference, which we would need to know what the radius is. So basically, we're finding the radius, and we're going to plug it in the circumference equation. So we'll do the same thing. 40 pi equals 1/8 times pi r squared. Pi's cancel. Multiply both sides by 8. Quick mental math, 8 times 4 is 32. Add a 0, so 320. Which makes sense if 8 times 54 is 432. 8 times 40, something smaller, is a little bit something smaller. And then equals r squared. And then take the square root. Now, it depends on how precise you want to be. If I take the square root of 320, I get 17.89. 17.89. So we'll round our intermediate calculation to that, and then plug it into the circumference equation, 2 pi times 17.89. Now I'm going to do a little experiment here, and I'm going to do 2 pi times not 17.89, but my answer. I'm going to use the answer button, because that gives us this whole unrounded decimal. And that gives me 112.40 if you round to the nearest hundredth. And then now I'm going to do 2 pi times the rounded version, 17.89. Okay, so we basically get the same thing. This would round to 112.41. But I just want to emphasize with you to be careful about rounding your intermediate calculations too much. So I might make a note in the Edulastic assignments to don't round your intermediate calculations until the very end. You could have also done 2 pi times the square root of 320 if you didn't want to round it to 320. Well, that would give us 0.40, just like this one. See, these are the same answers. So if we didn't round our intermediate calculations, our answer would be 112.40 and then meters. Now, let's say you were doing this on a test and you put 0.41. When I take points off, no, it doesn't matter that much. But just for the sake of like typing your answer into Edulastic, don't round intermediate calculations. And that's something else that you'll learn when you take like an AP Chem class or something like that. They'll be telling you that a lot. Okay, so that would be the circumference of the circle. And I'm wondering did I have more examples? I thought we had more examples on the other page. So if you flip your page over, if you're working on the worksheet, I'm not going to do all of these examples. I will just do, let's see. I'm not going to do the ones where you just kind of plug and chug into the formula. Let's look at number 4. It says the circumference of a circle P. The circumference, if you're an e-learner and you didn't get the worksheet, you're not really missing out on anything besides not having to copy down the diagram, but you don't really need to copy down the diagram. You just need to say what everything is. So the circumference is 12 pi inches. If the area of the sector is 4 pi inches squared, find the measure of angle BPA. So we're going to just try to find the measure of an arc. And it says, it gives us that the radius, it doesn't give us the radius. Okay, so we need to find the radius if we want to use the area to find the measure of the arc. So in your formula, you've got the measure of the arc, or the area equals measure of the arc over 360 times pi r squared. So we have the area. We don't have the measure of the arc. This is what we're trying to find. We're not given the radius, but what can we use to find the radius? They give us the circumference. So we're going to use the circumference to find the radius. So in the circumference formula, you have pi times diameter, which means 12 is the diameter, which means that the radius is 6. So that's how you figure out the radius. So now we're going to plug in the rest of our information and work backwards to get the measure of the arc. So we'll have 4 pi equals the measure of the arc over 360 times pi times r squared, which would be 36. All right, so pi's cancel. That's good. There are a couple ways you could go about this. You could divide both sides by 36, or you could multiply by the 360. One thing I would do is to see if 36 over 360 simplify, and they do. So this would be simplified to 1 over 10. Right, so now I'm going to recopy what I have left over. So I have 4 over here, and then I have the measure of the arc over 10. So all I need to do now to get the measure of the arc is multiply both sides by 10. And then I get 40 equals the measure of the arc, 40 degrees. And that is what they asked to find. All right, so that's how you would work backwards to get the measure of the arc. It really could have worked the same way if you divided by 360 and then divided by 36 and multiplied by 360, if you would prefer to do it that way. I'm trying to see. We'll do number 5. So in number 5, it says find the exact radius of a circle. So find the radius if the area of the sector is 36 pi. Oh, and I'm sorry, I don't know if this was very clear, but the circumference of the whole circle back in number 4 was 12 pi. The area of the sector was 4 pi. Okay, so that's why it seems like the area is smaller than their circumference, because this is of the whole circle, and this is just of the sector. I'm sorry if I didn't make that very clear. So this is saying that the area of the sector, I'm going to say S for sector, is 36 pi feet squared. And then the measure of the arc is 80 degrees. And they're asking us to find the radius. Okay, so we'll do 36 pi equals 80 over 360 times pi r squared. Cancel out the pi's. 80 over 360. First of all, you can cancel zeros. Second of all, is 36 divisible by 8? I don't think so. So they're both divisible by 4. That would be 2/9. So I'm going to go ahead and erase this, because I really should have written the simplified fraction first anyways. So this is 2/9. Okay, so now to get the 2/9 onto the other side, I would multiply by the reciprocal. So 9 over 2 times 9 over 2. Okay, let's cross reduce here then. So 2 and 36 would be 1 and 18. And then 18 times 9, I don't know, so I'm going to type it in my calculator. 162. So 162 equals r squared. Take the square root, and you get 12.73. Rounding, let's say I wanted to write this in simplest radical form. I would do 162. I'd try to divide it by different perfect squares, like 64. I'm not thinking that's one. How about 36? Nope. How about definitely not 25? How about 16? That doesn't really seem like it would work, because 160 would be divisible by 16. So not 162. 162 divided by 9. How about 9? Yep. So 9 and 18 work. And I mean, that's how I got the answer originally. So you should come to that conclusion eventually. So 9 and 18. And then I'm thinking, 18 is divisible by 9 too. So that means 81 should actually, 81. I didn't even think about 81. Okay, duh. So 81 and 2. 81 times 2. And then the 81 would come out as a 9. And then the 2 would stay under. So 9 square root 2 would be the radius. And is that what they asked us to find? Yep. find the exact radius. So when it says exact, and I'll make sure you know this in the edge elastic, when it says exact, that means simplest radical form. And if we wanted to be very precise, we would put a unit of feet. Okay, and I actually want to do one more example with you guys, which is number 7 on that page. It says the length of arc AB is 2 feet, because this is combining 11.1 as well. So the length of arc AB, okay, not just 2 feet, but 2 pi feet. And then if the measure of the arc is 20, what is the area of the sector? Okay, so a couple different things going on. Reminder, the length of an arc is found by taking the measure of the arc over 360 and multiplying that by 2 pi r. And we know that the length of the arc is 2 pi. We also know the measure of the arc. So we can use the fact that the length of the arc is 2 pi because we need to find the radius. Because if we don't know the radius, then we can't find the area of the sector. So let's do that. So 20 over 360 simplifies to 1 over 18. So this is going to end up being 1 over 18. Okay, and then something crazy happens here. The pi's cancel, but not just the pi's, the 2's. So the 2 and the pi cancel. So what do we have left over here? Not 0, but 1. Because 2 pi divided by 2 pi is 1. Okay, so equals 1 over 18 times r. And then now we just multiply both sides by 18. And we get that the radius is 18. All right, so now that we know the radius, we can use the fact that the area, wait a minute. Oh no, we're finding the area. So to find the area, we would just take the 1/18th fraction of the sector, multiply that by pi times 18 squared. All right, little pro tip for you. If you have 18 squared, but you're dividing it by 18 over here, then this 18 is going to cancel with one of these 18s, and you're just going to get 18 pi left over. So 18 pi, which if you type it in your calculator would round to 56.5 feet squared. Okay, and then I promise that is the last example for you guys. So, and then after this, you will do tomorrow's edge elastic assignment, and then we'll do a review assignment, and then you'll have a take-home quiz over the long weekend. All right, so that is the end of this lesson. Hope you guys have a great day.